Hey guys, we're Group F. I'm Michael.
I'm Aaron.
I'm Justin.
Well, the game that we chose to make was Connect 4.
We chose to do this game because it's a very interesting game with a large number of loops and booleans in order to create a real-life Connect 4 experience. All win conditions are checked for, and the game will continuously ask each player if they want to continue playing after each game ends. A separate win array is used to keep track of player inputs, and will check all win conditions after a player input.
The game is set up in a player versus player fashion. The code will not allow any invalid inputs while the game is running, and all win conditions, including vertical, horizontal, diagonal, and inverse diagonal, are all checked in the most efficient way possible.
A separate win array was used for the win conditions so that it could be checked efficiently, and the game will always continue to run through a while loop.
The first while loop is a boolean that will allow the game to continuously run.
And then we have two while loops within that loop that ask for player input, and it checks for the column that the players want to input their piece into.
So how the column-based input works is that the program will ask for a player to input a specific column, and if the player wants to input it in column 1, then the column variable value will be updated to 5. This simulates the actual Connect 4 experience in real life, because you will only be able to do it based on columns, and you can't put a piece, you can only stack pieces up instead of replacing pieces. So how the win array is set up is that if player 1 inputs a chip into a spot, it will say 1. If player 2 does it, it will say 2. So for column wise, the checker will always just check up, and then if as it goes up, it will stop at row number 3, because after you get from row 3 and up, you can't have 4 pieces going up, because that's illogical. Same for horizontal, it will always check this way, and the same thing applies after it gets to row 5. You can't keep checking because that's also illogical. And for diagonal, we try to do this in the most efficient way possible by using the player input from the column. So we take the first known position and then we check this way. And we also do this for inverse diagonal, because that is also an aspect of the game as well. Except for diagonal, it's going this way, inverse, it's going this way. And lastly, how we check for ties is that if all the columns values are at 0, so the entire board is filled up, then the game will say that the players have tied, and that it will also ask if we want to start a new game. This is an important part of our pitch, because our code is very efficient. It doesn't require a whole lot of running time. It will only check for things that are logical and not illogical, as in win conditions. It will never break. So even if a player inputs the letter S for board position, that won't work. It will just say an error, but the code will continue to run, and the program will also just keep asking the player for a valid input. All the win conditions, as we explained, are connected efficiently. And the code will also continue to run. It will also keep asking if the players want to keep playing.
Okay, so for the demo for our game, I've already started the program, as you can see. So there's only 7 rows or 7 columns in the board. So say if I put in 9, it'll return an error saying that I have invalid board position. And I can check for a win, say like horizontally, so I do 1. That puts a checker piece in column 1. And then I can do like 7. And I can do 2. And I can do 7 again. And I can do 3. And I can do 7 again. And I can do 4. And then it ends the game. And then it says player 1 has won. And then would you like to play another game? And I can press any key to start a new game. Or I can enter in for no, which would end the game totally. So say if I press like J, it would start a new game. So I could do, if we try to just keep stacking them up, once it hits the top, it won't allow another chip in that column. So this says there are no more space left in column 2.